All right. So let's take a look at Tic Tac Toe and see what we can do. Um, Before we jump right in, any big questions or anything particular that you want me to hit while we're going through, or we just want to do it as we go through?
I think just kind of as you go through, I mean, we got pretty far in it yesterday and just got like brutally hard stuck on defining one, like how to win the game,
Okay.
like how to get the like winning combination to, you know what I mean? Like
Yeah.
how do you check that? How do you display it? That part was like rough.
Cool. So we'll roll through some of the early stuff. Stop me, just holler at any time if you want to ask questions or don't understand what's going on. And yeah, we'll go from there. Sweet. So let's see. Share screen. Get everyone over here. Let's see y'all. Let's see the chat. Cool. So I have pulled it down. I just did a bundle and open it up in code. So let's take a look at what we're going to do here. So we're going to be building this Tic Tac Toe app, and we're just going to follow all the instructions here. That's the main, yeah. So we can run this, and it won't do anything now, I assume. If we just do, look. So it's got user brand Ruby, great. Of course, it is executable, so we should just be able to do. And thank you. You can go in now. Great, does nothing. That's what we want. We run our spec. It should give us all the errors. Yeah, perfect. That's what we want. Cool. Nope. No, thank you. Awesome. So let's see what we need to do here. We've got a tic-tac-toe class over here in lib. We don't have it yet. Perfect. Starting from scratch. So we're going to be defining a class there. Everything's going to break. Great. And we'll just walk through it. Sweet. Perfect. Everyone's over here. Great. See all y'all. So, class. Make a class. Tic-tac-toe, I assume. Ruby class. So, we want to set up the game and have it set to an array with 9 empty strings. Great. I assume that'll be 1, 2, 3, 4, 5, 6, 7, 8, 9. So we want to set a board variable equal to a new, and that's a instance variable. So that'll be part of the tic-tac-toe instance that gets set up. Cool. Oh, geez. All right. That's what we're going to do it. Cool. So in our, so to initialize, that's our constructor method. So we're just going to define that. And we want to make that board variable. And that's just going to be 9 empty strings, right? And that's going to be board. Let's get to an array with 9 empty strings like that. Perfect. I think that's all I want to do right here. Yeah. Cool. And win combinations inside that. Ooh, all right. Nope. In combinations. Yikes. Woof. Thank you. I want to type all those out. Let me copy that. Two, 3, 4, 5, 6, 7, 8. Yep, that's right. Cool. No Ruby formatter. Cool. So those are positions in our array. 0 indexed, 0, 1, 2 is the top row, 3, 4, 5 middle row, 6, 7, 8 the bottom row, and then down 0, 3, 6, 1, 4, 7, 2, 5, 8, and then across 0, 4, 8, and 2, 4, 6. 4 is the middle. Cool. Still not going to get any good tests, but should complain differently. Yes, perfect. Great. That's exactly what I want. All the errors. Because we haven't written anything yet. So helper methods, and this is almost all of it. All right. And yeah, it's hard to say that this is an example of good object-oriented design. There's a lot of choices being made here. But it is an example of how kind of building up small methods and then building your later methods out of that is really good. And that's a super like Ruby-ish kind of thing, but I think it's good in general. So great. Let's see. Define a method that prints the current board based on the board instance variable. I imagine it wants that to look a certain way. Yeah, okay. So it's going to be spaced out there with lines in between. Cool. So that method was called display board. So we're just going to make a board. Perfect. And we're just going to have it. Come on. There we go. We're just going to have it puts out all this stuff. So I'll make the lines. What do the lines look like? Those. Those. Oops. Copy. And then, I'm just going to copy this line here, and then we'll interpolate. Cool. So in here is where we want to do our putting the stuff in there. There's probably some fancy ways to do it, but I'm just going to interpolate normal like. And so that'll be board 0 and so on. And those have spaces. Yeah, okay, cool. 1. That's 2. And then 3, 4, 5. If this was a real thing, I would probably take the time to write this programmatically somehow. Because then you can be like, oh, the board's bigger. Do it 4x4, 5x5. And then you won't have to write that. But for now, this should pass that test. And that's all we care about for the moment. All the way up, all the way up. Hey, yeah, cool. Whew, got some greens. That's what we're looking for. Okay. Input to index. Pass a string and have it convert user input in the form of a string and have it return to us the corresponding index of the board array. Oh, okay, I see. So basically, this is just a method that returns -1, whatever you put in. We can do that, I think. So this is saying the user input. When we input a number, it's going to return 1 less because the user is going to be inputting 1 through 9. We want to return 0 through 8. No. I assume this is what it wants. pretty straightforward. And I think when they input something, it's going to be a string. So we need to do a 2i, I think. Yeah, that sounds right. Yeah. Because when we do an input, it's going to be a string. So, and Ruby cares about those things. I'm not going to test that just yet. We'll knock a couple of easy ones out first. Move method must take in 2 arguments, the index. And so this is actually taking the index, not the number, and then the token. So great. We're just taking in an index and a string and setting the index of that array to the thing. All right. So it's going to take index and player, we'll say. And then we're just going to say board index equals player. That seems right. I feel like it's a trick. Let's see. Seems too easy. Nope. Okay, great. That is correct. Cool. The position token will be responsible for evaluating. You can see whether it's occupied or not. After checking index values, might as pass the index value. It will see. Okay, cool. So it's just going to check whether or not it is a blank space. Cool. So we can just have it return. And this is one of the things we haven't done a lot of Ruby together. So one of the things that Ruby does is that explicit or implicit return at the end. So position taken, not token. And it'll take index. Yeah. So if I was writing this, even if I was writing it in Ruby, I would probably say return if it's equal to an empty space, right? Yeah. Yeah. So board index 2 equals not JavaScript, right? So if it is not equal to an empty space, yeah. So it's only 2, yeah. So I would probably do that, but since we're doing Ruby, that's the way we write Ruby. Once you get used to it, it makes a little bit more sense. I still find it jarring to read. I don't do Ruby all the time, but someone who does Ruby all the time, this is super clear too. So the last thing in a Ruby method is the thing that's returned. I like the explicit return because it's easier to read. But if you're a full-time Rubyist, then this is easier to read for you. So board index. So this is just the Boolean statement. Board index is not equal to empty string. And you're going to see this across any language with a Boolean thing. When you're first writing it, you're probably tempted to say something like, if board index is equal to an empty string, return false, else return true. Something like that. I see this in JavaScript all the time too. And these are equivalent, logically. And this might make sense. I mean, it does make sense as you're just kind of like going through the first time saying, oh, okay, if this is equal to this, I'm going to return true. If this is equal to this, I'm going to return false, or the other way around. Anytime you see return false or return true, you're just returning either the value of the thing you're evaluating or the opposite. So you can just return the expression itself. And remember, an expression is the thing that returns a value. So that is a super handy little trick that you'll see all the time. And definitely in the real world, when you do code reviews against your coworkers' code, people will definitely point stuff like that out. So that's a little top tip, something you just get it through practice. I'd still do it and then have to go fix it. So, or fix it. It works. Yeah, cool. Okay, valid move, return. What is a valid move? It accepts the position to check and returns true if the move is valid, false if it's not. Present on the game board and not. Okay, cool. So we need to check if the number is in the range that we want, and we need to see if it's also not taken. Cool. So let's call valid move question mark. Hey, look at that. Oh, because they're in the test file. So great. So we want to return, we're just gonna do the thing. So we need to check two things. Is it on the game board? So we want to take an index. Is it just take an index or just a token? Just the index. Okay. So we want to return true if it is not taken, and if it is between the numbers 0 and 8, right? Yeah. So cool. First one's gonna be index between 0, and that's a little range operator. Is it between question mark or just regular between? I think it's between, because most of the things in Ruby that return true, or many of the things in Ruby that return true or false, there's a question mark in the method name, which is nice, I guess. Makes it read more Englishy, I guess. So needs to be between 0 and 8. Pretty sure that's the way you do that. And it needs to have the position not taken. So not position taken. Needs to be between 0 and 8 and not position taken. And again, we're just returning the value of this logical expression. We could do if thens nested like that, but there's no need to. Let's make sure.
I have a quick question.
Yeah, go for it.
This is just like a syntactical thing, but so when you like tab complete the position taken thing and it doesn't fill in the question mark, like I'm assuming that it doesn't work unless you put the question mark in, because that's the question marks in your method, right?
Yeah.
And that's just a VS Code thing where it just doesn't fill in.
Yeah.
Cool. Thank you.
Real quick, sorry.
Yeah, go for it.
On top of that, what Charlie was asking, when you call it on your instance, you don't use the question mark. So if you made a board and then did, tic tac toe dot, and then which one did you position taken? You would not. Would you do the question on the question mark on the end?
Yeah, because that's just part of the
question mark.
Yeah, that's just part of the string, the token that is the name of the. Yeah, so you can write code that sounds like, oh, is this position taken? Question mark.
So that's like a common Ruby thing to have. Like a punctuation mark in a question mark, probably most likely in your names.
Yeah, and you'll see that in when we get to active record later on today. There'll be some that are question marks and some that are exclamation points. Because there's some things, I don't know if you'll see it today, but there's some things that's like, change this, like delete from this record. But then there's like delete exclamation point, which means delete it and write it to the database, or delete it and save it, persist it somehow. So those are the two main ones. I don't think you'll really see any others, but those are the two kind of like Ruby idioms that you'll see. Or like I think there's some maybe string or array methods that use the exclamation point too, where I don't know if this is one of them, but like, oh, do a sort and return the sorted array, or do a sort exclamation point and change the array in place. The exclamation point usually means like, do this for real, or do this destructively, I guess is the more but in either case you would definitely do it with the punctuation in the call. Cool, good question. let's see. So it looks like valid move is not working unless I look at the wrong place. Valid move is not working. Okay, why is it not working? Let's see. Index between question mark. Is that right? Is question mark right? Yeah, that's not it.
I think it's the comma. I think it's supposed to be a comma instead of the.
Oh,
two.
it's not a range. Yeah, you are correct. There we go. Yep. Cool.
Why is it not a range? Like it's a comma, just
Yeah, that's just the syntax of index between. If we do
oh, okay. Okay, so it's more like specifically to the between method.
yeah.
Okay.
Yeah, so that's just the syntax of the method. Cool. Awesome. So that works. Cool. Any other questions up to this point? Cool. All right, this one gonna need to do some more looking up in API doc. So this method returns the number of turns that have been played based on the board variable. And it says based on the board variable because I know it. We could keep a count variable or a turn number variable and just increment that. But we specifically want to look at the array. So the array is going to contain a bunch of strings. They start out empty, and as we fill them up, they get not empty. Turn count. So what we want to do is count the number of things in that array that are not empty. Yeah. And we'll be using the implicit return here again. So I'm just going to look at the board array. And I think it's count. Let me see. Let's just look up count. Yeah, that's right. Nope, that's not it. That's not what I want. I just want count. I just want count. Count array. That's what I want. Or numerable will probably work. Cool. So count will just give you the number of things in an array. So it's kind of like length in JavaScript. But you can also give it a function, basically lambda or whatever they call it in Ruby. Lambda's Python. I've been doing Python stuff, so lambda's my brain. An expression here, a little function. So this is how we pass in stuff to like the maps and the sorts and the reduces and whatnot, although they call them something different in Ruby too, or they call them something additionally. But basically this means that we can do give it a function and it'll count only the things that that function returns true for. So in JavaScript, I don't think there's something specifically comparable in JavaScript. I'll probably do like a filter and then length. This will do the same thing. So we want to do board count, and we want this function to return true for any square that is not equal to an empty space. So any square with a symbol in it is going to return true, and it's going to give us a count of turns that have been played. I think. Well, let's find out. So count, we'll just say it's an index, and we'll say board index is not equal to an empty space. That seems right. Like 80% sure that's gonna work. Nope. Okay, good. What am I not doing here? that's the way to do that. Forward square is that. Oh, it's not the index, it's the actual thing itself. So say like what is it? It's a position, I guess. So it's not looping over the indexes, it's looping over the actual things in there, like a filter or whatever. Pods. So we're saying for each thing in there, if the thing itself is not equal to an empty space, return true, include that in the count. That should give us a count. All right, 90%. Hey, there we go. Cool. So that's counting the occupied positions in the board. Questions about this one? And you'll see stuff like this a lot, I think.
We did 9 minus board count.
That will also work. That'll totally work. Yeah. Yeah, and you'll see stuff like this on the code challenge, I think. But doing it 9 minus count is probably the easier to read way. So yeah, either way it works though. Cool. That of course will break if we make it bigger, but we're not making it bigger right now, so we don't worry about it. Cool. I'm gonna leave this open because I bet we're gonna need to use it again. Current player should use the turn count method to determine if it's X or O. I assume X goes first. Yeah. Let's see if that assumption is correct or not. Current player. And take anything. So we just want to return. So if it's even, the turn count is going to be, so turn, we're starting with turn 0, right? Yeah, because it's going to be empty. So if the turn count is, can we just look up, can we just do even? I think it has a method for that, right? Even question mark, yeah. Cool. Is it even question mark? Then we're going to oh, ternary, because another question mark. So if it's even, we're going to return X, I think, and then O, or probably capitals, right? So we're just using a ternary there. Check if the turn count is even. 0 is even, so the first player is going to be X. Is that what they want? That's what they want. Cool. It works for the 3rd and 4th moves anyway. Any questions about that one? We're starting to get into tricky territory, I think. Cool. It's a pretty straightforward ternary. So, great. Turn. Oh boy. Okay. Here we go. So that also works. You can also do, I think if you do like a logical and like a 1 bar 2, that'll return, I don't know, there's a bunch of little tricks of various complexities and efficiencies, and rule 1, whatever works. Efficiency is rule 3, so don't worry about that until later. But yeah, mod 2 works totally for sure. That is what I would do in every other language. Binary had a lot of little helpers for you. Cool. Build a method turn to encapsulate the logic of a single complete turn. A lot of stuff. Cool. So we're going to grab them with the input. Get input. How do you do input? It's command line. It's like gets. Yeah. So we're going to grab The next line from input. Perfect. We're probably gonna want to yeah. So we will remove any white space just in case they well, it's going to return the character return at the end, so we're going to get rid of that too. So grab the input, pull off any white space. Number one. We're going to need to prompt them, which I imagine is going to be something specific. Move, turn count, turn. Is it asking for something specific? I don't think so. Cool. And we'll just say, hey, give me the next thing. Translate into input value, index. We got that. If it's valid, we can do that. Make the move, we can do that. Display the board, we can do that. If it's invalid, ask for a new move until the valid move is received. Okay. Oh, and they gave us a little thing. And for ask for input, get input, index. If it's valid, do that, do that. Otherwise, keep going. All right. That feels like a lot of stuff. Cool. Let's start off here. Turn. Cool. So we want to prompt for input. Enter your move. Say it's 1 to 9. 1 to 9. Cool. And now we want to do gets strip, and that will get it and remove the white space and return that. So we'll say oh, move is already taken. Use your move. Equals. So we're grabbing that and putting it into a variable to use later. Next, we want to translate that into input. So we can just do, actually, let's just do it here. Input to index. So it's getting it and then passing it directly into input to index, getting it the index there. Call it move index. It feels better. Cool. So now we're going to check if it is valid. And we can do, yeah, let's do the if. Valid move. Move index. Then we'll do some stuff. Else we'll do some other stuff. Cool. So if the move is valid, we are going to make the move and show the board. Easy. We already wrote that stuff. Move, index, and player. So the index is the move index. The player is the current player, which we already did. So going to make the move, pass it to the current player, which looks at the turn count. Back. And then we're just going to show the board, which was display board. Cool. I think that's all I wanted. Cool. Otherwise, we're going to restart the turn. So, so there's a few ways to do this. Could put this in a little while loop, but I'm going to do it the cheap way, I think. I'm going to call turn again. So let's go here again. So it'll ask me to enter my move again. I could wrap this whole thing in a while loop and say, while, or I'd have to get that first, and yeah, messier. This feels good, and it'll, this has some, stack limitations if they mess it up like 1,000 times or whatever. They're gonna have a bad day, but I think they were already gonna have a bad day at that point. So, input the move, get the index, check if the move is valid. If it's valid, make the move with the current player, and then show the board. Otherwise, go back and try again. Yeah, I feel good about that. Like 75% good about it. Let's see. All right, look at that. Okay, we did it. Cool. Now we'll get to the part where we had trouble. So before we get to the next tricky part, any questions over here?
Just a quick question to clarify. So gets itself just gets whatever your input is, like whatever the user was inputting. And
Yeah, so gets the
okay.
next line from the input of the program. And if we're just running it on the command line, that's going to be typey. We can also, like pipe text to it from the command line, and that would take each line of text from the file or from whatever the program is sending it. But in our case, yeah, it's going to be standard input. Yeah.
Is user input from gets always going to come into the program as a string?
Yeah.
Okay.
That's why we have to do the 2i up here. Because we're gonna get that. It's basically like give us a big string, not a big string. It's gonna give us a string, probably with a carriage return on the end. So we want to pull off that return and then turn that string into a number.
And then is there a way to and I guess this might be more advanced enough to talk about it right now, but is there a way to limit their input? So if we're looking for a number 1 through 9 that they can't type in like peanut butter sandwich or
so from the command line, not really, because and this is a good philosophical point, I guess. We're running on a Unix machine. Unix machines run programs that have input and output. A Ruby program throws to its output through puts and gets from its input from gets. If we just run it on the command line, then we're just typing stuff and that's going into the standard input. There's no way to limit what someone types on the command line, right? You can type whatever you want here and that's going to go into the program. Similarly, if we have a text file full of moves, we have moves.txt, we can just pipe it into the program like that. Tic Tac Toe. So this will take that. This basically says take that text file and throw it to that program, or we can cat the file, then pipe it in like this. So this is the pipe says take the output of the previous program and send it to the input of the next program. So it's just like plugging those two things together. So as far as our Ruby program knows, it's just getting input from somewhere, whether it's the command line or from a file, or if we have another program that's outputting stuff and sending it to that. It's just getting input. So we need to account for any input that comes in and then handle it thusly. One of the kind of philosophies of Unix program design is be generous in what you accept and be strict about what you output, because every program from ls to a complicated web server is going to have input and output, and you don't know where that's coming from. So when you write a program, and this is good advice for programs in general, or life in general, I guess, is you don't know what you're going to be getting in. You can get literally anything from anywhere. So take what you get and then make sure that you process it or evaluate it in some way that it's going to work for you. And then when you're putting stuff out, try to only put out the stuff that you said you're going to put out. Or programs or anything else. So yeah, short answer, no, there's no way to restrict what comes in because it could come from anywhere. And that's the same for like web stuff, right? We have an API we're going to be writing or using it somehow, and and people are going to be sending stuff to that API from the internet somewhere, right? So we can say, oh, I'll take it and log in as user or update this record or whatever. But we don't know who's sending stuff or what format it's going to be in, or if it's conforming to the API docs that we wrote. So when we write a backend API, we want to be able to validate the stuff we're getting in, because even if we like put up a nice web page with a form that doesn't let you type in anything but numbers, they don't need to use that. They can use Postman or whatever else and just send it straight to the API. So although you can make a nice UI will make it easier for the user to put in the right things, it's not going to stop someone from putting in bad things. So always be what you're accepting. Don't assume it's going to be what you want, and make sure it is in the right format and is not going to damage your stuff at all. In game development, the phrase is the client is in the hands of the enemy. You can't assume that even if you're on a secure socket to whatever multiplayer game thing, that someone's not going to be bypassing the client entirely and sending whatever garbage to cheat or break your shit or whatever. So yeah, always validate, and make sure you send out as good stuff as possible. Yeah, long answer. No. Was that useful at all? Cool. All right, enough putting off the hard part. So it's an easy enough ask. Our one method will return false or nil if there is no win combination present in the board, and return an array containing the winning combination indices that should be, if there is a win. Your win combination is constant in this method. Cool. So we're returning false or nil or an array. So here's our win combinations, graciously supplied by Chris. So we want to see if, let me think about this. We want to take a look at that array, and we want to see if it contains a winning, if our current board matches a winning thing. Let's take a look at some array methods. Let's get a list of array methods here. Maybe, okay. If any of the things, maybe that's what we want. Very, very useful. Okay. Great. So I don't know if this is any of the material or not. This is just one of the things you kind of like, I don't know, feels like half the time when you're learning anything, you start by doing it or trying to do it in a way that you're used to. So we've learned JavaScript a bunch, so we're going to write some JavaScripty feeling thing, regardless of what language you're using. And then slowly you get used to the sort of idioms of the language that you're using and start writing it in more that dialect of logic, I guess. And sometimes you do that through just experimentation. Sometimes you do that through reading other people's code. Sometimes you do that by just like trolling through the documentation, and seeing what there is. And when the documentation is not super great formatted, it's harder. Or read books that list everything out for you. I think this is one of the things that Rue pulled from some other places that's really nice. I think JavaScript has implemented something like it now. Is there has some and every. Yeah, it's getting close. I think some is the equivalent of any. So we're going to take our collection, our array, and call any question mark on it. And it's going to return true if the block, that's what they call it. The block ever returns a value other than false or nil. So that's a clue that we're on the right track, because it's going to return false or nil from that thing. So if the block ever returns anything but false or nil, it's going to return true. And that's what where are we here? That's what we want from here. We want to, we don't want to return true. We want to return the combination. Okay, cool. More steps. So we'll do our winning combinations dot any, and then we need to pass it something, right? So the combinations are in our array here. So these are the things that it's going to be checking after. Let's start off there. Win question mark? One question mark. That's it. One question mark. And again, there's lots of ways to do this. That's kind of like talking through a way to do it. Also nil. So we're going to use our win combinations array. Let's start off with any. That feels like the right track. So we're going to use a block, and we can either use, well, let's see. Object will cause anything to return true. So if we don't call it with anything, it's gonna just call great, cool. That's not what we're doing. So if any of those combinations, so if any of these combinations returns true for the thing. So I think it's going to be more than one line. So I'm going to do instead of a block with curlies, I'll do a little do block, which is the same, just reads a little better. So do combination combo, sure, yeah, combo. So this is the block we're going to be looking at. If this block returns true for any of the combinations, we're going to return from that, right? Okay, great. Let's talk through this. So we want to look at the block, and we want to say, so this is going to be an array of three things. 1, 2, 3. Okay. So, and we could do this with like we could loop over it, I guess. It's kind of doing that implicitly. We're just kind of like, and he's just kind of an inside out loop. So for each combo, which is a 3-item array. No, this is this is a little bit trickier. I mean, so you could go well, let's talk through this way and let's talk about some other ways to do it too. So we want to say if all three positions are the same. If all three positions are the same. Yeah, right. Okay, that makes sense. So we'll say, so the expression that's going to return true for us is board combo 1, 0 equals board 1 equals board 2. So that's saying, so that's going to return true if they're all equal and false if they're not. And this is going to fail. Because why is that failing? Unexpected equal equal. Why is that failing? My brackets. 4, 0, 4, 1, 4, 2. Why is that giving me an error? Let me just do one. I'm curious about this error. Combo 1, combo 2. Yes, we do. Yep, we do. That's right. Because it's not well, like Perl does that. Old Perl brain, wow. So yes, ands is what we need. So if they're all the same, that should check if they're all the same. Great. Hey, look at that. Returns false for a draw. I don't know why I checked that, but it's not return the winning combo. So we want to return the winning combo here if just return the combo, right? And this is still going to fail because, oh no, it's not. It should fail. I guess the test is not written well. Let me see. In here. There's one. Can anyone tell me why this should not work? Or why it should work, but it's going to fail sometimes.
I'm not even sure I can tell you exactly why it's working.
So we're looking through yeah, and this is not obvious, I don't think. This is just like the Ruby way to do it. So win combinations is our array of positions that will win. So we're going to check to see if any of those positions satisfy this block, this little mini function kind of. So for each one of those combinations of 3 things, we're going to check and see if the first one equals the second one, and if the first one equals the third one. So if they're all the same, we're going to return that combination. So that's what we want. And otherwise, the documentation said that if it doesn't, it's going to return. What's going to return? Otherwise, false. It's going to return false. So does that make sense? That we're checking to see if all the 3 things at these positions in our current board are the same. So if they're all, if position 0, 1, 2, say. So we'll look at 0, 1, 2 is board 0 and X. So we'll say look at positions 0 and 1. If those 2 are the same, if these are an X or if these are an O, then check if the first one and the second one, the third one are the same. If that's an X or is it an O, and we know those all have to be the same because they're all equal to each other.
Would this also fail because wouldn't it also check if they were empty?
Yes, exactly. It would absolutely fail, or it would not fail. It's not failing, but it would return the wrong thing. Technically, it's always going to work because it's probably never going to run this until one move is made. But if we wanted to be picky about it, which is probably good. We would say, what's our method up here? If position taken, board 0. And so if there is something in that position and all 3 of the winning spots match, then return that combination. Otherwise, if none of those are true, then it's going to return false. And that should still work. Cool. So yeah, that still works. That's a Ruby-ish way to do it. I don't think anything of this complexity is going to be on the code challenges, so this is a nice to know. What are some other ways of doing it using this array?
I might be confused, but isn't that still hard coded to only hit the first win combination?
No, because it's looking through all of them. So it's looking at win combinations. So it's the whole array here. And saying if any of the things in this array satisfy this condition, then return true. So it's going to go through each one of them and say, is this one going to work? No. Is this one going to work? Is this one going to work? And so on. So it's going to check each one of those. And if the first position is taken and all 3 positions are the same, then it'll return the combo. Does that make sense?
I guess I just don't understand why it's how it works, not just for the first line, the first top 3 spaces.
So this is the way that any works. So any is going to look at each item in the array and run a block for every item. So as long as one item in the array satisfies that block, it's going to work out. So it's not just looking at the first one, it's looking at each one of these arrays in here. Does that make sense? Can you kind of talk me through what you're thinking?
I guess back down on the one helper method. It's not the any method. It's the board combo 0 and the board combo 1s. It just seems to me like those would be hard coded to be the top 3 positions. I don't really understand why it's not.
So combo in this block here is going to be, so for the first time through, this is going to be the combo. So this is combo 0, combo 1, and combo 2. And that's going to check this next one. And combo is going to be this array. So this is combo 0, this is combo 1, this is combo 2.
Okay, I get it now. I get it now. Thank you.
So the 0, 1, 2 are not the positions in win combinations. They're the positions in each array in win combinations. That's a great question. That's a easy thing to get caught up on.
Can we also have just a quick look review at when you wrote if position taken ? And then put in the board 0 index value and just adding that little part there. I just want to know what that's doing.
So basically the way we had it before, we were checking if all 3 were equal. If they are empty, they would also be equal. So I guess after the first move, it would always return good for a win because someone would move somewhere and then one of the winning combinations would always come up as a 1 because all the empty spaces would be equal to each other. So we need to make sure that the thing that we're checking, which again is, say this one here, we want to make sure that this actually has an X or a 0 in it before checking to make sure that they all are the same. Because if it's empty, it's going to say, cool, it's empty. Is this one empty? Yep. Is this one empty? Yep. Great. Someone won. And we don't want the null player to win. Does that answer your question? Or make any sense?
So it's just, so this board 0 next to position taken. So position taken is asking if the value that's in board index 0, if it's
not an empty string.
If it's not empty, then we'll execute the rest of.
Yep, exactly.
Okay.
Yeah. And apparently the test passed without doing that, but let's be good programmers. But yeah, if this was, oh, I broke it there. 4-0. What did I break? That should not work at all. If this was for a job and someone else was writing the tests, yeah, that's not right. What did I break? If someone else was writing the tests, I would be like, cool, that passes. Write better tests. Or I would write a better test myself and it would be better. But yeah, let's make it good. Position taken. Combo 0. And double check that I didn't break it again. Come on. Cool. Okay. Again, it's super tricky bit. Other ways to do it. So we have this list here. If we're using this, I feel like any way we're going to do is going to be checking to see if those are A not empty and B equal to each other. And we could do that with a loop, a bunch of different ways probably. This is just like the Rubyest way to do it, I think. Cool. Any questions before we move on? I think the rest of it's going to be pretty straightforward. Awesome. Cool. Full method should return true if every element in the board. Great. And so any has a companion method called all. That basically does the same thing as any, except it checks for all. So that's in JavaScript, that would be some and every. Those exist. So we just want to say for our board, we want to check to see if the square is not empty, right? Oh. We can just say board all. And then we just say position taken, position. So this is, again, going through our board array, which is the strings, and it's gonna, if all of them pass this condition, which is looking at the position, returning whether it's taken or not. If those all return true, this should return true. Otherwise, it'll return false. Does that work? Nope. What did I miss?
Curly brackets, right?
Curly brackets. Yep, that's it. There we go. Does it work? Nope. Returns true for a draw, returns true for in progress game. Position taken is saying, oh, it's not looking at the position, it's looking at the actual thing. So we would just say pause is not equal to. And if we wanted to go like full Ruby on it, we'd probably write a little method for that to check if the thing is taken, but it's not asking for that, so I'm not going to do it. Nope, still no good. If position is not equal to, what am I doing wrong here?
Isn't that just checking if all of the positions are not equal to?
Yeah, so we want it to return true if every square is not equal to the empty space. Oh, question mark? You got it. I would like to say that I'm just playing dumb to let you guys learn, but we'll just say that's the case. Cool. So it's pretty straightforward. If all the things in the board are not equal to an empty space, the board is full. Great. What does a draw look like? Returns true if the board is full and has not been won. Cool. So, and again, now that we've written all these methods, all the stuff's kind of fits into place. Draw, question mark. And we just want to return if it is it full? And is it not one? Question mark. So if the like literally now we're just writing English if it's full and if it hasn't been one. Hey, there we go. Cool. Is it over? Returns true if it has been one or the board is full. So same thing. Def over. I was going to say if the board is one or is full. Or full. Yeah, now we're just plugging methods together. Cool. And now for the winner. Cool. Winner says, given a winning board, the winner method should return the token X or 0 that has won the game. So, given a winning board,
Can we just use 1 to check for a winning board?
Yeah, so win is going to return the winning combination. So it's going to return that 1, 2, 3 array there. So winner given winning combination. If combo equals given a winning combination. If given a winning board, we have the board already. The winner should, so we're going to use 1. Right. So we'll say the winning combo is 1. And then we'll just return what's in one of those elements, right? Because that's going to be, every one of those elements is going to have the winning thing in it. So we're just going to say, return board, combo 0. Doesn't matter which one you use, right? So we're running 1. 1 is going to run, and we're saying we assume that there's a winner. So 1 is going to return that combination 0, 1, 2, or whatever it is. And then we're just going to look at whatever's in one of those. We can look at any of them. And that should return the winning thing. Right? Sounds right. Returns nil. Well, there's no winner. If yeah, that feels right. Because it'll not return anything if there's nothing there. So if the combo 1, we're going to return this. I don't think we need to put return there. Otherwise, nothing's happening. So it's going to return nil. Which I don't think it said. It didn't. Yeah, right. So it's checking to see if because one will return false or nil. So checking if there's a winning combination, return that thing. Otherwise, it's going to return nothing because nothing happened. That feels good. Okay, now the playing. Yeah, or we could use a ternary. Same deal. You could say combo 1, board combo, :nil. All right, play method. Oof. I think this is gonna be okay, right? Any questions up to this last bit? Cool. So until it's over, we're gonna run a turn. Then we're gonna check to see if there's a winner. Is when it's over. Yeah, so we can say, oh yeah, it's easy. Play. So we can just say, so we could say while not over turn end. While not over turn end. That'll work. Ruby also has an until, which happens after. So we could do this. We could do turn until over. No, the same thing. Just a more Ruby-ish way to do it. But that's just like the opposite of a while, just on one line. Cool. So it's gonna run turns until it's over. When it's over, we want to see, is it gonna ask us for a specific Cats game? Okay, congratulations X. Congratulations O. Okay, cool. So we need to either output congratulations winner or Cats game. Okay, prints Cats games on it. Does it say that in the spec? Okay, cool. Weird. So let's see. So it is over. We will have a winner. So no, we may have a winner. So if there's a winner, it's going to give us the winner. Otherwise, it's going to give us nil or false. So we can say if winner. No, we can do a ternary. Puts. Yeah, well, I looked at your chat and it's the right answer for a different thing. We're going to puts winner question mark. So if there's a winner, we're going to put out what's it? Exact string, congratulations, winner, exclamation point. Just boom, boom. And that'll be the winner. Winner. Otherwise, it's going to put out. I've never heard it called Cats game. Cool. So if it's going to play until it's over, if there's a winner, it's going to put out the winner string. Otherwise, it's going to say you drew in a weird way. Okay, moment of truth. So close. Oh, that's not what we wanted. Okay, turn until over. Why would that not work there? Checks if the game's a draw after every turn. After every turn. Did I ask for that? So over should return true if it's a draw, right? So it is still checking over. It's full. Is it not checking for a draw? I don't think it's checking for. Oh, did I just do full instead of draw? Over. One or full, i.e. is a draw. And I'm going to check for draw just in case. If it's one or if it's a draw. Nope, no good. Okay, so what did I do wrong?
No, that's right. You got rid of that error, I think. There's the errors are in the bin tic tac toe file.
Okay. So that's not my problem. Cool. Well, all my stuff worked. They probably just want to put one in there, and yeah, I'm just checking lib. Bin can take care of itself. Oh, I guess it should instantiate instance of new tag 2. Okay, great. Fine, we'll do that. That is my problem. So we'll just say game equals new tic-tac-toe game play. All right. Yeah. Cool. I think that's it. Oh no, what did I do wrong? Game equals new tic-tac-toe. Oh. Let's try writing Ruby instead. Yeah. Not JavaScript, it's Ruby. There we go. Much better. All green. That took a hour, 20 minutes, give or take. Cool. So that is an awful lot of stuff. But that does exercise a lot of plain old Ruby that we're using. Something like this. I know tic-tac-toe is a deceptively difficult problem sometimes. There's some fun ways around it. There's the 15 game. It's isomorphic, but yeah. The checking the winning positions is always the weird thing. You could also do it where like it's a magic square, and then you check if any of them add up to 15. And you could do that with any in those combos, but you still need that combination of winning stuff. And there's programmatic ways to do it that are slower, but we don't care about slower really at this point. Yeah, it's a fun, I don't any game. Tic-tac-toe, clearly the simplest, dumbest game. But any game, and people discover this during their phase 5 projects or other projects. Games are usually more difficult than you think they're going to be. So there's all sorts of weird little things like that you have to catch that programming languages for some reason just aren't shaped right for. But this is a great review of all the any and alls and all your definitely want to look at your sorts and maps and reduces filters and all that stuff. I think they're also called something else in Ruby. I can never remember the other names. But yeah, that's tic-tac-toe. Bada boom. Questions, the turn method again. Yeah. Tell them what to do. We get the new line, strip it out, change that to an index number. That's our move index. If that is a valid move, then make the move with the current player that we're getting here, and then display the board. Otherwise, try again. Questions? All right. Go ahead and stop sharing. So that was a lot. Thank you for sticking through it. Yeah, that was a lot at Mark speed. So it will take you more than an hour and change to do something like this for sure. Code challenge, not this complicated, definitely. We'll have some stuff that you'll need to do in the additional methods, but we'll practice that. Yeah, I think I've talked for long enough.
I just have one kind of follow-up. Sorry. So the reason we chose to start doing this one is because when we kind of looked through the curriculum that's on in our record right now. This is the only one that seemed like it is code challenge-esque, and I don't see anything else that's like, this is definitely the thing that we should do to prepare.
Yeah.
Is there anything that currently exists in the curriculum that we should be looking at working on that's like close-ish? Because like normally there's like a Toy
Yeah.
Tales or something that's like, this is kind of like the code challenge, and I just didn't see anything.
Yeah. I don't know if those are, I think they might not be published yet. I can double check. Wait until after the lecture today, because you'll be doing active record then, and you'll be getting a better idea of what you're gonna, what the base is gonna be that you're gonna be building stuff onto. I definitely have some stuff. If there's not stuff in the curriculum, I have stuff that I put together that we can review to make sure you're getting all that stuff you need. Yeah. But if you can do this, code challenge should be very easy for you.
So Matt yesterday in the chat definitely made it seem like active record was kind of the meat of the code challenge.
Yeah.
This phase. So
But it is it's kind of like the base of the code challenge. If you can't do active record, you can't do any of it. And so you're basically like, you have 3 models that have a relationship. You hook those up with active record, and then we're going to be adding on a half dozen methods on top of that. They're like, get the highest value from the thing that's associated with this, or print all the names from the thing that's associated with this. And I'll show you examples so you have a more concrete idea of what that looks like.
awesome.
Yeah. Yeah, phase 3 code challenge I think is the easiest one by far. So pressure is dropped here.
I mean, to be fair, that's what you said about this entire phase, and I
Yeah,
like that. So
but
I've
remember how bad it was.
Yeah, I've basically not felt good this entire week, and I don't know.
yeah, I've taken literally double the amount of notes that I've taken for any other phase. I'm not even like all the way through the material, so it's going to be easier statement makes me think a little dubiously.
Yeah. I'm like, okay, this is supposed to be like somewhat easy or whatever. I'm like, I must just be stupid, because like I was like, this doesn't make sense. Like,
I think compared to the other ones where we're also learning all the new stuff, I think this is the easier one. All the other ones are also very hard. So yeah, definitely not stupid. It's just a matter of doing, and it's a new language, so that's not great. Yeah, you'll definitely get it by the time we do this code challenge. So not worried about it at all. Cool. Any other questions before we break? Awesome. Thanks for hanging out. I'll post this video in the usual places. Lecture in like half an hour-ish, so I'll see you later on.
Thanks, Mark.
Thank you.